Good morning, afternoon, night, depending on in what time zone you are. My name is Jiri Cincura, and today I will be talking about kind of a new feature in the C# language, C# compiler, and it's called source generators. You can find me on Twitter. The Twitter handle is on the screen, and also you can check my blog and find all the other links that I will be talking about on tabsoverspaces.com. So without any further talking, let me jump into what actually source generator is. So in C# 9, so one version back, the C# compiler introduced a feature called source generators. It's actually a feature that was requested maybe from the beginning of the C#, and you might know from other languages, mostly like C++, and macros, basically a way to create kind of your own constructs. Source generators are a similar feature, but slightly different or very different execution. So what we can think about the source generators is that it's kind of a meta programming during the compilation. It's some kind of code generation during the compilation. So what I mean by that is that basically as your code is compiling, some extra process is started, and that allows to generate an extra code, and this code will be included in the compilation. It's more or less the same as if you would have an external, maybe a PowerShell script or maybe Python script that generates some source code, and then you recompile your code or something like that. The benefit is that you are running inside the C# compiler, and you have access to all the trees, all the syntax trees and so on from the compilation, so you don't have to do your own parsing and other stuff. If you look at the picture, how it actually works, we can see that from the left, the compilation starts, and then we have kind of like a sidestep into the orange area where you analyze the source code some way, one way or the other, and then you generate a new source code. You don't have to. You can say, hey, there is nothing I can do, but obviously sometimes, or most of the time, you generate a source code, and the source code is actually included in this compilation run. It's not like you need to run it twice or something like that. And then the compilation resumes, and it's like nothing happened. You just press F5 or something in Visual Studio, or type like .NET build or something like that, and at the end of the day, at the end of the pipeline, you have the final result. So what we can actually use it for, there's a couple of areas that are really interesting and really fit nicely into this, but even today with the C# 10 and let's say 1 year, a year and a half after, people are coming with interesting ideas for source generators. Even Microsoft is now providing some source generators that can maybe not do something that was not possible before, but help us something to do faster, or with less allocations and something like that. So let's start with the list that we have here. Probably the easiest one is something that works with reflection. As we probably know, the reflection is, I don't want to say slow, but it's definitely slower than a normal like hard-coded code. So if you are working with serialization, deserialization, and this kind of stuff, then you can, during the compilation, inspect the code and generate extra pieces that you know, hey, this is this property, this is the constructor, and so on and so on. Similarly, if you are doing some kind of parsing like XML, JSON, and so on, I will show you some example directly from the .NET 6, and you can write parsers that have very little allocations, or maybe no allocations, or maybe are absolutely focused on one specific format and allow you to generate some classes and other stuff. Obviously, strongly typed APIs, there's the same kind of story, and it's even like generated during the compilation, so it's not generated dynamically through some proxies and other stuff. So you might provide a definition, and it will generate REST API client. It might create a special API for accessing a database, for example, from some definition, and so on and so on. There's a there's a bunch of these that can generate from WSDL and Swagger and these types of documents. Obviously, you can also generate some, I call it dummy overloads, or maybe a combination of overloads. Maybe you're writing a library, and this library provides a method that takes like an integer and double and string and different combination of these. And sometimes it's not enough to have a default values, because yeah, it's not always possible. Or you have a method that takes one parameter, 2, 3, 5, and so on, until some number, and then maybe an array or something like that. And if you need 1 or 2, that's fine if you type it manually. But if you need to create like 16 overloads, similar to what, for example, Task has or something, or even you say, hey, I want to be on a safe side, I want to have 32 overloads, then it becomes a little bit more difficult to type this by hand, or maybe even creating a different combination. So even if you have like, hey, just 16 different overloads, but you have 3-4 types, then suddenly the combination is like enormous, and you might have like, I don't know, like 500 overloads. Then it's absolutely not possible to write or maintain this by hand. And finally, a p-invoke or any type of interop. So we can have classes be generated from header files, for example, or we can have the p-invoke, as I mentioned, and other stuff where you basically creating, again, it's some kind of API that you are generating. In this case, it's a slightly different because you are dealing with interop, so you might be actually putting everything together. So you are generating API, you are generating some kind of stuff for reflection, because you might be marshalling data back and forth, and so on and so on. So there's a few limitations in the source generators that you should be aware of. And in the future, these might be lifted, or we might actually realize that we can live without changing these limitations. So the first one is that the source generators are only additive. What it means? It means that they cannot modify existing code. So they can only add extra methods, extra classes, and so on, basically adding a new code. You cannot modify one. That does not mean that you cannot modify existing classes and existing methods. That obviously works, but these classes need to be partial, similar stuff that we have when we have some kind of generator, like in the WinForms. When you are generating the WinForm, then you have the designer file, and then you have your own file. So you can only add code, you cannot modify code, but you can add code into existing classes and so on. The reason why you can modify code is obviously, so it's kind of, you can kind of see the result, because suddenly when we open the gates for modifying an existing code, it becomes a whole different story, because suddenly you can change how something behaves. It's not clearly visible. You might be changing completely the stuff, like changing changing from, let's say, from class to structure, which completely modifies what is happening in the code, and so on and so on. It's a completely different game. So you can only add. The next one is that you cannot specify any order. There's no order in what the source generators are running in, which looks like a huge limitation, because, well, what happens if this one runs first or that other one's first? But if you think about it, you can only add code, and the source generators are seeing the state of the files when you start it. So even if I generate some extra interfaces, extra methods, the other source generators will never see that one, because all the generators are kind of running in the same state. So that's the state I started with, like, hey, I stopped typing, I press like F5, or I press build, and at this point, all the source generators are seeing the same code, so you cannot see what was generated. The source generators, which is not kind of the limitation, but also worth mentioning, can add extra diagnostics. By diagnostics in Visual Studio and compiler, we are describing stuff like errors and warnings and messages and other stuff. So basically the green and red and other squigglies in the Visual Studio that you have, you can use source generators to generate these too, which is nice, because sometimes your source generator might say, hey, I didn't find anything in your code, which is weird because I'm enabled. Or, hey, I find this class, but I didn't find the other class, so I cannot work. So maybe you forgot to have a public or something like that. Obviously the source generators can use so-called additional files, some extra files you have in your project. So it's not only about the C# files, it's also about other files that you have in your project. Obviously the C# files you can process too. So without any further talking, because we are a little bit limited on the time, let's jump into examples. So here, let me make it a little bit bigger. I have a simple, where's my project program.cs? A simple project. It's a simple console app, and I have a few generators in here. Normally, you would install the source generator as a NuGet, or that's probably the most commonly used scenario. So you install a library, and the library has some kind of source generator, or you install just the source generator. They are distributed normally through NuGet, and you don't have to install it into the Visual Studio or something like that. No, it's part of the project, meaning that you can generate the source code even if you are building on a build server, building from command line, and so on and so on. But I have it here locally as part of my solution. That kind of works as well. Sometimes you need to reload the project because if you generate something really new, syntax highlighting might not catch up, and you might not be able to dive into it, and so on and so on. So sometimes reloading the project or even restarting the Visual Studio is the best way to do. But that's because I have everything in one project. So kind of I'm compiling my own project with my own source generators. So let's start with the easiest one. It's called Hello Conference. And if I look into this source generator, we will see the structure, what we actually need to do. So the source generator is something that implements iSource generator. This interface is pretty simple. There is an initialize method where I will get some kind of context, like what's the project, what's the file, and so on and so on. And the execute method that actually means, hey, do something, generate something. I don't have to implement the initialize. Well, I don't have to even implement the execute. It can be empty method, but then it's kind of like empty method, right? So the execute method is the most important one because that's the place where you are generating something. The initialize might be used to initialize some extra data structures that you might use and so on. So you don't have to do it during the compilation, during like the execute phase, to be precise. You will see that in a second. So that's the interface. Then I have the generator attribute on my class, and that's about it. I don't need to have anything else. It just works out of the box. You can compile it, put it on NuGet, and that's it. As you can see, my initialize method is empty because this source generator is really simple, so I don't have anything extra in here. And then I have the execute method. The execute method at the end adds one or more extra files, extra source files. So that's what we see here. There's a context.addSource. This is the file name, which should be not conflicting with other files, but it should be also stable. So don't put there like GUIDs, random numbers, and so on, because if you want to check what was actually generated from within the Visual Studio can find the file if like the name is stable, and especially if you are rebuilding the project, if the name is the same and if the content is the same, then the Visual Studio does not need to recompile something from scratch. So again, it's something that you can choose, but it should be kind of stable. Usually when you are generating something and adding something into the file, you might have like my file .generated.cs or something like that, right? Then I include my my string builder, and I create source from, and I say, hey, it's a UTF-8 encoding that's more or less given. And in my case, it's pretty simple. My string builder is right here, and I will actually generate the code here as part of the string. If you are doing something fairly simple, you can just be fine with some string builders and appending stuff together. If you are doing something more elaborate, you might be using some kind of maybe templating language or something like that to make it a little bit easier for you, because as you can see, it's a little bit messy. especially as you are generating C# code, to recognize like, hey, this is part of the string and the other part is part of the normal code. Especially for me, at least when I'm generating something, I'm always kind of confused with the brackets. I know these are with different color and other stuff, and I can even have like a string to be, I don't know, bold or italic or something, but still it's a little bit confusing. So actually what I'm doing here, I'm saying using system, some kind of namespace with C#10, I could even make this one a little bit shorter. Then I create a static class with a static method called say hello. This method puts on the console hello conference, and a little extra step that it will call this method get syntax tree outputs. And this one, what it will do is give me a bunch of strings, and it will go into the context, which is the stuff that I'm getting in as a input parameter. Inside this context, I can check the compilation, the current compilation, and all the syntax trees, basically files that the compiler sees and that the compiler will actually compile. And I will put console write line into the say hello method. That's it, nothing really specific. So we can actually see what files the compiler sees during the compilation. We can see that it's the program.cs definitely, but we will see there's a few more that are automatically generated unless you set that they shouldn't be generated. So let's run this one. And we can see, let's make it a little bit bigger, that there's a hello conference, and then there's a bunch of files. So there's the program CS. Then there's also the generated assembly attributes that by default the new projects define. And there's also the assembly info just generated as well. You can see it's in the OBE and it was included in there. So that's pretty simple stuff. If you want to see what was generated, you can obviously just F12 into the code. It says you, hey, this is auto-generated file. You cannot edit it. So there's even no reason to edit it. And you can see all the stuff that was actually generated. Usually when I'm writing source generators, I don't care about the formatting and other stuff. So when you see some output of some other source generators, don't be confused. That it's not formatted and it might be kind of like left and right and up and down. It does not matter for the compiler. And sometimes it's just easier to just put it there and that's it, as long as you have like correct semicolons and brackets and other stuff, then it's fine. And the compiler definitely does not care. So that was the simplest one, but you need to have something that's a little bit more interesting. So let me close these CSproj files because we don't need these CSproj files. Nope. And I have one that I call CSV Classes Generator. That's kind of in the area of like parsing maybe, or some kind of like pre-generating some objects or some stuff for parsing stuff. So what I have here in my project, in my source generator project, I have this CSV file. It's called participants and has a name, role, and an email. Simple CSV file. This might be an example file or something like that. And in the runtime, I know I will be parsing this CSV file. And it would be nice if I have a class for this type of CSV generated for me with a name, role, and email. So I don't have to write it manually, and more importantly, I don't have to maintain it manually. So if somebody comes later in next year and adds extra field or removes a field because, for instance, email, GDPR, we don't want to have an email. If I remove it, it will be removed from the parsing and from the class and so on and so on. So what I'm actually doing here is, again, in the execute method, I'm checking all the additional files. So it's not the C# files, it's the extra additional files that I have in here. In my case, it will be the CSV file. I check, hey, is it a CSV file? If not, then just continue because it might be other files that you have in your project. Then I get the file name and so on and generate a class for the CSV and so on. And then I add the source with the name of the CSV, underscore generated or dot generated, and again the source text. So what I'm actually doing here is that I open the file with the stream reader, I read the first line, which is the header, and I split it on the comma. Then I get the string builder, as usual, and I create a namespace that I call CSV. Hard-coded namespace, sometimes it makes sense to have the same namespace as the project or something like that, which you definitely can. I will show you that in a second. Then I create a public class that is the same name as the file name without the extension. So participants.csv will create a class called participants, and I will create a public class called item. You will see in a second why is it called item. And in this item, I check all the fields, all the pieces in the CSV file, and I just generate public string, the name and the getter and the setter, and then I close the brackets. So far, so good. So what this allows me to do is that if I create this item, for example, for some kind of serializer and deserializer, I can just click and I will say I will have email and I will have name and the role. Simple enough, right? But what I can actually do is open the participant and say, hey, we will be also capturing the address. So I type the address, go back, press the dot and build, because it's not building for some reason. I don't want that. And there I have it. There's address. Pretty simple. And obviously, as I mentioned, well, we don't have address. We don't want to have address and email. I just have a name and the role. Does not matter what's left there. I will save it. Let's hope it recompiled automatically. Now it kicked in, and there's only the name and there's only the role. No email, no address. So kind of, you might say, it's kind of the same as having something outside of Visual Studio generated for you. And just having this process to be there. This is kind of like a streamlined version of that. I modified the CSV, it was automatically generated. I might have created a class, again, it's automatically generated. But there's one more thing that we can actually do, and I think that's really nice, and it's probably the most powerful part of these source generators, because so far what we have seen, what I've showed you, is it was basically generating the code. And you can do that you could have done that from the day one. Just create a simple Python script and run it as part of your build pipeline. And that's it, generate some extra pieces. Because parsing CSV, I can do that in the Python and other stuff. But the next one is a little bit more interesting. So this one is kind of, let's call it a little bit useful, at least in the real world. It's again a normal generator, but this one uses two extra or two specific options that you can use in your own. The first one is that I am generating, where is my code? There it is. I'm generating a file all the time, and this file contains this piece of source code. So it's a simple attribute that's called auto notify with a attribute with a name with a property called property name, and I'm always generating this one. So if you install my source generator, I will immediately generate this attribute, and you can start using it, which is actually what I'm using here. I'm using the auto notify attribute here on a field. We will see in a minute what it actually does, but you probably can guess it right now. So that's the first one. Your source generator can kind of bring into the project all that's needed to enable it to start using it, some extra classes, attributes, methods, and so on, and generate it all the time. So as long as you install it, you kind of have like extra tools in your toolbox. The other part is what I have actually here is that you have all the structured information about the compilation, about the source code available. What I mean by that? Well, let's jump into this one. So my compilation, I will cast and say, hey, it's a C# compilation. I will check the first syntax tree and some kind of options, depending on what options the C# compile is using, and I save this one. So that's the first one. Then I can check all these compilations and check what's actually in there. But because I don't want to do this in the execute method, in my initialize method, I have something I have a method on the context. Well, that was not correct. There it is, context. And there is a register for syntax notification. So whenever something happens in the source code, some syntax event happens, my code will be called. And what I have in here is a so-called syntax receiver. Let's check this code. It implements iSyntax receiver, and there is a simple method called onVisitSyntaxNode. So whenever a compiler is visiting a code and it's a finished syntax node, it will call me and I can do something about it. And what I'm doing here is, whenever there is a syntax node visited, whenever the compiler goes through the code and there's a like full finished syntax node, I will check, hey, is it a field and does it have any attributes? And that's it. I'm not checking anything else. I'm kind of like pre-filtering what I might be interested in the future. And because in my code, I'm interested in fields with an attribute, it's kind of a good filter. Obviously, I might have a different attribute. I might have fields that I might not be able to process and so on. But I'm storing it in this candidate field, something that might be useful. So that's really, really powerful stuff, because suddenly you can inspect the full source code. You can check, hey, is this file, that file, this class, is this namespace, and you don't have to manually parse it out. You can just use the power of the C# compiler. You can use the power of the Roslyn compiler to do this stuff and have all this all these pieces available for you. For example, this field declaration syntax contains all the stuff you need to be able to understand what is the field. So you have these modifiers, and you have the semicolon token. Where is actually the semicolon? Is it on the same line, on the next line? Is it indented, and other stuff? I know it's probably completely useless, because who cares where the semicolon is? But you can get all the information the C# compiler has. Basically, the C# compiler needs to have really, really precise specification of your source code in some kind of object tree, and you can get access to all these informations in your source generator, even stuff that you might not need, because it does not matter for the source code, but does matter for the compiler, or at least, well, it does not matter for the compiler. Like the placement of the semicolon probably does not matter for the compiler. But still, it's useful to know where the semicolon is, because if you're, for example, generating a new code and you want to be like super special compliant with what the developer is using, you might say, hey, he or she is putting the semicolon on a new line for whatever reason. So I will put it on the new line as well. Or the brackets, opening and closing brackets and other stuff. You might have some logic built on top of this. Obviously, most of the time you don't care. It's a generated code. If it's a generated code, then the analyzers that you might be using in your project for like syntax and other stuff are not being executed on generated code, because, well, it's generated. But you might enable it, you might want to have it, I don't know, you just have all the stuff that's available there. So I have, for example, the modifier, so I know, hey, is the private, is it public, is it read-only, is it static, and so on and so on. So everything I have in there. And there's also a base class, so there will be probably more stuff, and it's a member declaration, so there will be probably more stuff in here, well, not much, and it's a C# node. So I, for example, have the parent and other stuff to be able to access basically the full tree. So that's really, really powerful, and I like it, because for me personally, like 5 years ago, if you've been generating some code or analyzing the code or maybe changing the code, it was really, really difficult. There were basically two options. First, use some regular expressions that might or might not work. If it's in your like internal project, then fine. You might say, well, I know how the code looks like. But if you are creating something that your team and the other teams and even the public world might use, there's a bazillion of options. People can write the code and how you should parse it in the regular expressions. We know that you cannot parse reliably, for example, the C# code or HTML or other stuff with the regular expression. And the other was obviously writing a parser. And writing a parser for a programming language is really difficult. If it would be easy, then, well, everybody would be creating parsers and NuGet would be full of parsers for C# or other languages. So there were only two options. Full parser, really, really difficult. Regular expressions, still kind of difficult, but easy to do, especially if I want to just rename some classes and other stuff, then it is easier. But with the power of Roslyn and with the power of this one, it's really, really easy because, well, you have the power of the official C# compiler. So, well, as long as the Visual Studio compiles it, you know you have all the stuff you need. But let's jump into my code. So in my execute method, I will check, hey, give me the type by the metadata. In my case, auto notify attribute. So I have this symbol. Then I have another, let's call it a reference to the interface, and it's the iNotify property changed from system component model. As you can probably guess, my auto notify or this auto notify attribute, the notify property generator, is automatically generating the iNotify property changed interface for all your fields. Then I will check all my candidate fields, all the fields that I during the initialize phase or during the syntax receiver that I kind of collected in my code. I will get a semantic model. I can get a semantic model. It's not just the syntax, it's also the semantic model. So I can actually reason, hey, is this a method or is this a property? Or is this a method returning integer? Is it the integer? That's awesome. Or is this type the same as this type? Meaning, are these methods compatible or something like that? That's really, really powerful and really, really awesome. So I will get the semantic model, and I will basically enumerate through all of the stuff that I have. So in the field, I will check what's the variable of the field, all the variables. And then I will get the field. I will check whether there's at least one attribute of the attribute symbol. And you can see I'm not actually comparing strings. I'm actually comparing like objects, like types. This attribute symbol is not a string. It's a variable called with the type iNamedType symbol. So even if somebody created auto notify attribute, but in a different namespace, in a completely different place, it will not match because I'm not matching on the strings. I'm matching on the types. Obviously, if you are doing something yourself, you probably select, let's say, a specific enough name. But sometimes you are generating stuff that is actually like object and integers and other stuff, and you need to make sure that you are not working in a project where somebody redefined integer, or you are in some part of namespace where object means something else. You might be saying, why would somebody create an object called object? Well, I've been in projects where in some namespace somebody needed something that was called an object, and they defined an object. And suddenly you have like two objects. You have the object from the C#, everything is an object, and suddenly you have this type of object. The compiler will be able to resolve that. But if you're comparing strings, you might be comparing other stuff. So I'm comparing here like strongly typed stuff. And yeah, if it has all the attributes that I need, I add it into these field symbols. Then I group it by the containing type. So I take all the fields and I group it based on the type, and then I start processing the stuff. So I process the class, process the containing type. So I will add an attribute into it. Sorry, not the attribute, the, how's it called? Interface. So as you can see, I will generate a public partial class. the name of the class, then the notify symbol to display string, which is kind of like a toString. So it will tell me, hey, it's the iNotify property changed. Then I will do the public event, property changed, event handler, yada, yada, and then I'm processing the fields. So again, in the process field, I will just say, hey, what is the name? What is the type? Because I need to generate a property for that. I will get the attributes. I will again get the attribute. And from that, I would say, hey, is there a property name? If so, if my attribute contains property name, then I will use it. If not, I will start guessing the name of the property. So this is the choose name, which is a really, really stupid method. It basically says, hey, remove the underscore at the beginning. If there is nothing, well, there is nothing. If it's just one, make it upper, and everything else is just, hey, make the first one upper, and the other one is just whatever is there. And then, well, I generate the remaining stuff like the getter and the setter with the property changed and the invoke. We will see how it looks like. So let me build this one. And if I create instance of my class notify and have the car, if we check what's in there, well, it's my partial class called notify, because that's the name of my class. It implements iNotify property changed. By the way, it's quite common that instead of generating the usings, you use the full names. It's a little bit easier. You don't care that the code is longer and other stuff, and you don't have to fiddle with the usings and globals and other stuff. So there's my property changed. This is my car property. It says, hey, it's this car, or set the value, and then is this property changed, invoke like this, and this is the property changed event args. And if I create an extra property instead of car, I will say like train and save it and go back there. Well, suddenly I have a train property. And what I can also do in the auto notify, we saw that property name equals test, for example. And if I go back there, suddenly it's called test and not the train. So I can even like rename the property in case it's not matching some naming and other stuff. But it's purely the logic in my source generator. So this is what the source generators are about, how you can write it, and what you can do about it. But all that I was showing you now was how to create it. And creating these source generators is fun. I like it. You are exploring how it works in the C#. You are generating a new code. Yeah, and as I said, I like it. That's the way how I learn about new stuff and how I understand how it works. But obviously, for common scenarios like the notify property changed, there's a great chance that somebody already created the source generator and even created a better one than this one, because, well, it takes a couple of iterations to make it really nice, or maybe even simpler or something like that. Anyway, so you can go to NuGet and you can start exploring. If you Google or Bing or whatever for source generator and the problem you have, there's a great chance that if it's a common enough problem and somebody already created a good one, or somebody started and then abandoned the project, but you can take the code, probably if the license allows it, you can take the code and start your own and make it even better. But as I mentioned at the beginning, .NET now comes with source generators. The team around the .NET and all the projects around Entity Framework and ASP.NET Core and other stuff. So these teams are adding a source generators around these, or even the base class library, to help with something. So not only you can create and you can download an extra stuff, there's stuff included as part of the .NET to help you do other stuff. And what I have in here is one example of this one, and it's a practical one. And you probably know, if you've ever written some kind of serializer or deserializer, that most of the part of the serialization or deserialization is actually going through reflection and finding all the properties and constructors and calling the getters and the setters and the constructors in correct way and creating from properties the names of elements in XML and JSON and other stuff. So basically most of the time is some kind of logic working on the metadata of the object. So you are checking, hey, which constructor I can use? Is this property public so I can use it, or I should use it? Does it have a public setter so I can actually set it? Or basically a logic around the metadata. And this takes time because, as I mentioned, the reflection is slower than a direct code. But with source generator, what you can do is actually during the compilation to pre-generate all this stuff. The constructors, the properties, and other pieces. It's really simple, right? You can do it in the compilation, so you are not doing it in the runtime. You are not doing it all the time during the runtime, and during the compilation you have basically all the time you want, more or less, and you already know that the code will not change, because as I am pressing like build, I know that whatever happens to be the output is the output. Nobody is gonna change it later. Well, you can still modify the IL later using the PostSharp and Fody and other tools, but from the compilation perspective, it's not going to change because, well, I'm compiling it right now. So that's the idea behind the source generator that I'm showing you right now. So you probably know the Json Sterilizer from the system text JSON, the new JSON namespace available in the .NET that allows you to serialize and deserialize stuff. So I have here a simple class, a person as ID, first name and the last name, kind of stuff that you might get from the database. And you might be taking this and shoveling it through ASP.NET Core and sending it over the wire. You are creating some kind of API. And because you might be handling thousands and thousands of requests every second, then the serialization and deserialization might take a significant portion of this time. But what I can do now with the .NET 6 is create a partial class, whatever name, and inherit from Json Serializer context. This is purely so I have a bunch of there is a bunch of methods and common type for the stuff. You don't have to implement anything yourself. As you can see, my class is completely empty, and I will fit two attributes: JSON source generation option, basically saying, hey, what type of options you want for your JSON serialization and deserialization, and what types I'm actually going to serialize. So in my case, it's a person. There's a bunch of other options and you can do it a different way. You can check the documentation. This is basically the easiest one, how I can show you something. So I'm saying, hey, give me the stuff for person, the stuff being, hey, give me the metadata. The property will be camel case in the output, and it will be indented, right? And then in the serialize method, I can put an object, the normal stuff, but there's also an extra overload that takes this JSON type info of person. And if I check my context, my JSON context, the default that was generated, and then it was generated for a person because the class is called person. So if I would rename it or something like that, I don't know, like test, then you can see there's no person and I need to change it to test, right? So let me put it back to person so it makes a little bit sense. And I can call serialize or I can call deserialize. The result, the outcome will be the same. It will serialize or deserialize the content, no change in there, but it will do it a little bit faster. I don't have any measurements, any benchmarks because it's not that interesting. We know it's faster and there's a lot less work to do in the reflection, and you can try it yourself, but it will be faster for you. And that's the only thing you need to do. Just create this and use this extra parameter in serialize or deserialize. Similar stuff in .NET 6 is available for regular expressions, because the regular expression is basically a description, really tight and really compact description of some huge part of code that is actually parsing the string. And instead of doing this in the runtime, and even in .NET in runtime, you can have the compiled or the interpreted one, you can actually like pre-generate the stuff completely or partially as part of the regular expressions. And you will have it in the code. You don't have to do it in the runtime. Same stuff. So if you are doing a lot of stuff with regular expressions, again, interesting stuff in there in .NET 6. Again, you can check the documentation. Just Google with Bing or Bing with Google and to see what attributes you need to put there and other stuff. So with that, I am out of time. I hope you enjoyed the source generators. You will try writing some simple one for you, generating a simple method, maybe a different toString or something like that is really easy to start with. Obviously, once you move into generating other stuff like we have here, it's a little bit more difficult. We can actually check what was generated. So for the person, it actually generates a stuff for the serialization, deserialization. There is also there is a what is the constructor, there is a what is the property. So you can see it's generating a stuff it's called like info0, which is the ID, and what is the data type and other stuff. Then we have the first name, again, what is the data type, so it's a JSON string, and other stuff like that. Is there a setter, is there a getter, and other stuff, and so on and so on. It basically pre-generates everything like that. So it's a little bit more elaborate, but again, it's still the same story. Whatever I'm doing, in this case, in the runtime, I can do it in the compilation time and save it into some structures and include it as part of the project. So with that, I'm not sure whether there will be any chat or questions and anything. If so, I hope I am there and answering your questions. So you can post your questions in there. If you have any other question, feel free to go to topsoverspaces.com. You can find the contact information for me there. You can send me an email, or you can find me on Twitter and send it through these channels. Hope you enjoyed my talk. Hope you are enjoying the rest of the conference, and see you next time. Bye.